You know, when something fails in a piece of software, what's our first instinct? We just try it again, right? We hit retry, and it feels like the most logical thing in the world. But here's the thing. While retrying is absolutely essential for building stable systems, that same simple action can also be a system's worst enemy. It can unleash these just catastrophic failures. So today, let's really dig into that dilemma. Okay, so I'm sure you've heard this quote a million times, right? Insanity is doing the same thing over and over again, but expecting different results. It's a classic, and yet it's a principle we have literally built directly into our software. When a request fails, what's the system's first move? Usually, it's just to try again. But, what might be smart for a person learning from a mistake isn't always so smart for a machine. And that brings us to the first really crucial idea here. Not all failures are created equal. I mean, not even close. And figuring out the difference between, say, a temporary hiccup and a permanent roadblock, well, that's the key to building systems that don't just tear themselves apart. So it really all boils down to this one distinction. Retrying is fantastic for what we call transient failures. Think like a temporary network glitch or a server that's just busy for a split second. Chances are, if you just wait a moment and try again, the problem will be gone. But retrying is completely useless for permanent failures, right? If you send a request with a typo in it, sending it 100 more times isn't going to magically fix that typo. So for now, we're going to focus on retrying those good transient failures. Because, and this is the crazy part, that's where the real danger is hiding.
All right, so if we're only retrying for these good failures, what's the big deal? Well, it turns out that in today's complex systems, retries aren't just some nice-to-have feature. They're actually a mathematical necessity. And it's right there, in that necessity, that things start to get really complicated.
Okay, let's start with a single, super reliable service. Imagine it has 99.99% availability. We call that 4 nines in the industry. And that sounds amazing, right? I mean, that means it's down for less than an hour over an entire year. Pretty solid. But here's the catch. Modern applications just aren't built that way anymore. They're not one single block of code. A single click from you, the user, can trigger this whole complex chain reaction, calling a bunch of other services behind the scenes just to get the job done. So let's just say our service depends on, 5 other services. And let's imagine each one of those is also incredibly reliable, with that same 4 nines of availability. Everything should be totally fine, right? Well, no. Because when you start chaining these services together, their tiny, tiny chances of failure start to multiply. And all of a sudden, your overall availability drops to 99.95%. Now, that might not sound like a huge difference, but that actually translates to 5 times more downtime over a year. Ouch. So this creates the central problem for anyone building these kinds of systems. We need that 4 nines reliability, but the very way we build things now seems to be working against us. So how do we get back? How do we close that gap?
And the answer, believe it or not, in its simplest form, is retries.
And what's cool is the math works out almost perfectly. For this exact scenario, just adding 2 retries is enough to fight back against that cumulative probability of failure. It pushes our overall availability right back up to that 4 nines we wanted. So, problem solved. Or is it?
Yeah, this is where that elegant, simple solution can twist into a catastrophic problem. It happens when one of those services you're calling isn't just having a tiny momentary glitch. It's when it's actually starting to drown under the load.
There's this quote that just captures the idea perfectly. It is like you're kicking it where it hurts. I mean, think about it. When a service is already overloaded, it's already struggling, and then you hit it with a flood of retries, that doesn't help it recover. It's like kicking a machine that's already sparking and smoking. You're just pushing it that much closer to a total breakdown.
So let's walk through how this actually plays out. Imagine your service at the very top makes a call. It fails, and it decides to retry just once. That's it. A single, completely well-intentioned retry.
But remember our setup? Our service depends on 5 others. So that one single retry at the top, it instantly turns into 5 new requests, all hammering the services one level down the chain.
And what happens if each of those 5 services also has its own retry logic? Well, now you're starting to see the terrifying math. Those 5 retries explode into 25. We call this retry amplification, and it is a feedback loop that just grows exponentially.
And just like that, you've created a full-blown retry storm. What started as one tiny failure and one simple retry has cascaded into this massive self-inflicted denial of service attack. This is the kind of thing that can take a service that was just a little bit slow and knock it completely offline, leading to these long, painful outages.
So, here's the bottom line. We absolutely need retries to get that high availability we were talking about. But we also desperately need strategies to stop them from causing these storms. We have to retry, but we have to do it smartly.
Okay, so the first line of defense is on the client side. That's the service that's actually making the call. First, you implement what's called bounded retries. That's just a hard limit, so you never end up retrying forever. Next, you use exponential backoff. This is key. Instead of retrying right away, you wait longer between each attempt, say 1 second, then 2, then 4. And you add something called jitter, which is just a little bit of randomness to that wait time. That stops all your clients from retrying at the exact same millisecond, which would create what's called a thundering herd. And finally, for the ultimate protection, you use a pattern called a circuit breaker.
The circuit breaker pattern is it's brilliant. It works exactly like the circuit breaker in your house. After a certain number of failures, the circuit opens or trips, and for a little while, it just stops sending any traffic to the struggling service. This gives that downstream service the critical breathing room it needs to recover. Then, only when a tiny test call gets through successfully does it start to let traffic slowly ramp back up, which prevents the whole thing from failing all over again.
But look, smart clients aren't enough. It's a two-way street. The server also has to protect itself. For one, it can apply back pressure, basically telling clients, hey, I'm overloaded, back off. It should also avoid wasted work. I mean, if the original caller is already timed out and gone away, there's no point in finishing up that request. And when things get really bad, it can start load shedding. That's where it deliberately starts dropping less critical requests so it has enough resources to handle the important stuff and, stay alive.
So, we've looked at why we need retries, the incredible danger they pose, and some of the solutions. What's the one big takeaway from all this?
It really is this. True system resilience is a partnership. It's not enough for the client to be a good citizen if the server can't protect itself. And it's not enough for the server to have all these guardrails if clients are just going to hammer it relentlessly anyway. You absolutely need both sides of the equation, smart clients and robust servers, working together to survive the failures that are just inevitable in any complex system.
So that's where we're left. A simple, everyday retry can be both a system savior and its destroyer. And as our digital world gets more and more complex, more interconnected, you have to wonder, is the idea of a perfectly resilient system just a myth, or is figuring out how to retry without going insane the next great engineering challenge for all of us to solve?